Alright, so let's talk a little bit about potential energy. Now, potential energy is stored energy. So, energy that's just waiting to be released. So, it's kind of just like maybe a rubber band that's waiting to snap. Or a bow just ready to be launched into an arrow. Because of my potential, there's a pretty good chance that I would be decently messed up if I fall off this cliff. Opposed to, let's say, a curve. That wasn't so bad, right? Now, if we want to calculate potential energy, it's pretty easy. All you have to do is take the mass of the object multiplied by gravity, which is, of course, 9.8 meters per second squared, times the height of the actual drop. So if I were to calculate my potential energy here, that's a pretty big drop. Yes? Yes. But you might be asking yourself, what if it's not a straight drop?
Whether it's a straight drop down, sliding down at an angle, or dropping down a bunch of steps, either way, the potential energy is going to be the same because the total height of the drop is the same, no matter which direction it takes. But now, for the most important question,
what is the unit for potential energy? Well, all energies, just like work, the unit is the joule. So let's see how we can use that in our calculations. Welcome back to the classroom. Now let's talk a little bit about potential energy. As we learned earlier, potential energy is mass times gravity times height. So let's check out a problem. How much potential energy does a 3 kilogram book have if it's lifted 2.0 meters? Let's pick out what we know. We know it has a mass of 3 kilograms and a height of 2 meters. But wait, aren't there 3 variables? Yes, but we already know one. Which one is it? That's right, it's gravity. So let's plug it into an equation. If potential energy is mass times gravity times height, we have a mass of 3.0 kilograms times gravity, which is what? That's right, 9.8 meters per second squared, and a height of 2.0 meters. I'll give you guys a second to work out that calculation. That's right, 58.8 joules. Easy as that.
That's the sound of sunshine coming down. And that's the sound of sunshine.
All right, that is quite the hill. So the next area of energy that we're going to be looking into is kinetic energy. And kinetic energy is the energy of motion. So as you might assume, if I start going down this hill, I'm probably going to pick up a good deal amount of speed. And the more speed I gain, the more kinetic energy I gain. So, getting a little nervous. All right, so let's see here. Let's get going. Duh! So, I'm getting a little faster. I'm getting a little faster. My kinetic energy is through the roof right now. So another thing to note about kinetic energy, just like with potential energy, the unit is the joule. And so whenever you make a calculation, do not forget about that. Alright, so we're pretty confident about stored energy. Now what happens when that energy is unleashed? Well, you get kinetic energy, which is found by the equation 1/2 times mass times velocity squared. Easy enough. Let's check out a problem. How much kinetic energy does a 1.4 kilogram book have if it is tossed across the room at 3.0 meters per second? Pick out what we know. We know that it has a mass of 1.4 kilograms. We know it has a velocity of 3.0 meters per second. And I think that's all we need. So let's plug it in. If kinetic energy is 1/2 mass times velocity squared, and we have a mass of 1.4 kilograms and a velocity of 3.0 meters per second squared. I'll give you guys a second to work out that calculation.
Are you having fun? You look like you're having a great time.
Yes, that is the correct answer. It is 6.3 joules. Way to go, kid.